Welcome to the Rare Earth Exchanges podcast, where power, politics, and the world's most coveted materials collide. Rare earth elements power the backbone of tomorrow's most critical technologies. With China dominating global production, the U.S. and its allies must align strategically to ensure a stable future. This urgency prompted tech entrepreneurs Daniel O'Connor and Dustin Olson to launch Rare Earth Exchanges, a news and insight platform built to equip stakeholders and decision makers with the tools and intelligence needed to reduce dependency and build prosperous resilience. Let's get into it.
Welcome, everyone, to the Rare Earth Exchanges podcast. You're joined with me, Daniel, and a special guest, Wade, who is the CEO of AML Magnetics. Wade, welcome to the show. How are you?
I'm well. Thank you for having me today.
Great. Hey, Wade, so you guys are in the magnetic space. We would love just to get a quick intro from you, like what your background is, how you got started with AML, and then, of course, just what AML is doing today.
Yeah, so AML has been around actually since 1995. It was actually founded way back in 95 in the back of a robotics automation company, and specifically targeting high energy physics, a lot of particle accelerator kind of work. And around 2004, the robotics company was sold to a big public company, and they told the lab it needed to get out of there. And so it moved along. And then around 2 years later, the robotics company and the founders of that were looking for something to do. They had already been minority stakeholders of AML. And so they decided to reorganize AML into something for commercialization. Among those were a chief scientist, actually my father, Mark Senti. He was one of the founders as well. And so they reorganized it. They started focusing on superconductivity. But around 2014, 15, they realized the market just wasn't big enough. That was around, there's a lot of wind energy and power generation. Superconducting generators were kind of the thing, but the market just wasn't big enough. And around that same time, the chief scientist came up with an idea around producing permanent magnets using a similar process as they used to produce a superconducting wire. And so they stewed around a business plan, started to figure it out. Around 2016, filed some patents. And then around 2017, I was actually looking for something new. I came from world in finance and was looking for something new. And my father at the time was trying to figure out how to position the company and what to do. So end of 2017, I joined the company as a consultant. I worked with him strategically to figure out how to finance it, who to find in terms of our plan. And so around 2020, I came on full time. We met our first strategic partner then. And that was the path that we went. We've worked with Defense Innovation Unit, the DoD, the Department of Energy with RPE, DoD with the Defense Logistics Agency up through the present time. So your question of how I got involved in AML. So it's going to be a great story, but it's actually a really sad one. Is my father actually passed away earlier this year. And so him and I were co-running the company. The board, approved me as president of the company. I've been on the board of the company for 2 years as well. So that's kind of the story of how I got involved. There's other important people along the way. Our current CTO, Dr. Philippe Masson, has been involved with our company since 2008, off and on. He came on full time in 2018, and he's helped us craft our technologies to where they're at today.
That's great. Sorry to hear about your father passing.
Yeah, our condolences, Wade.
Absolutely.
Yeah, and no, and it's we've been very fortunate to have a lot of folks around us to move things along. But like I mentioned, him and I were pretty much neck and neck in the thick of it. As you know, within the rare supply chain and the magnet supply chain, it's a very dynamic and interesting place. Sometimes it feels like it's rinse and repeat in terms of where it's going. But I think this year there's a lot of difference. So
that's great. So you kind of alluded to it here in your introduction, but let's talk about some of the why behind the technology. What was a problem you were originally trying to solve when you started this company, and how's that evolved over the last few years?
Yeah. So, one of the things that making centered neodymium iron-boron magnets is it's very laborious. It's very difficult. You have 7 to 8 steps. A lot of them require to be in an inert environment. And so one of the things that we had looked at with this sort of powder and tube process is to be able to, one, cut the amount of steps down, and two, be able to manage and deal with these materials. At the time, we were not working with other materials, which I'll allude to in a minute here. But that was sort of the genesis of it, is how can you have a process that reduces the labor cost? Because like most know, producing sintered magnets, 60 to 70, up to 70% of the cost of the magnet is the material, which is a real challenge when you're trying to move that production in places outside of China. And one of the things that we also realized that's not exactly talked about as much today was a lot of the alloy compositions for making sintered magnets there's a lot of IP that revolves around it, not just the manufacturing process, but the actual creation of the alloy compositions. So in the beginning, we actually did not, we were looking at sintered magnet manufacturing with this process, but we also did a freedom of operating and really looked at the IP landscape. So we started looking at different magnet materials, different neo materials, looking at samarium iron nitride, which is used for injection molding, looking at manganese bismuth, which is a material that's been commercialized out of Ames lab here in the US, and looking at these different types of magnet materials and producing magnets with them. And so over the last couple of years, we've been qualifying these different types of materials with our process for applications such as motors, generators, some of the bigger sort of the bulk of the magnet application base. But maybe a long answer to a short question, but the process in its own right is not just, we're moving down the process of automation, but the actual fundamental process removes steps, reduces labor cost, makes material handling a lot simpler, reduces waste, and then on the other side of the actual process is our electromagnetic technology. So that's what really is the enabler. There's trade secrets, there's no IP on it. It is 100% how we are able to magnetize magnets in single pieces in different directions, and which opens up the magnet design space incredibly, which allows us to look at applications a lot differently. And the third piece of it, which probably should have been the first piece, is our CTO and our team have developed a suite of software tools, and essentially software tools that can look at magnet applications, specifically motors, generators, and others, to be able to effectively try to build the best application with a wide space in terms of magnet design. We did a lot of that before we actually refined our process. My father always liked to say, we put the cart way in front of the horse, because we've done hundreds and hundreds of design studies from everything from power tools to EV motors to aerospace, motors and generators and applications. And that's sort of how we refine the technology, and we've come up with new stuff along the way. But the goal is ultimately to compete in an environment where cost and environmental regulations, et cetera, are quite, higher, what you see in the Western world.
So Wade, I heard 3 components. That third component's intriguing. I had the image of a CAD software. You know how you'll use CAD or PLM, product lifecycle management software, to in aerospace, as an example, right? Is that sort of what you and your dad developed for magnets?
So our CTO, Dr. Philippe Masson, he developed around 2000. So 2 things. One, we use off the shelf this engineering design software, but there was a program that they had been working on with NASA it was a hybrid electric propulsion, like a superconducting generator, and it lasted 4 or 5 years. It ended, I think, around like 2012. But during that time, developed a lot of tools and software tools that were sort of integrated together to be able to look at magnet applications and analyze and design, electrical machines and different things like that. And so that it combines with, traditional sort of engineering CAD type of tools, but it allows us to be able to, we bank a lot of data. We're able to go through, and look at applications very quickly, figure out if, on some of the configurations that we're developing, have the ability to, 1, be doable in terms of physics and everything else. And then 2, what we've actually implemented over the last 2 years was the manufacturability of it, and incorporating the different material types, incorporating a bunch of different elements so when you actually somebody approaches you and says, hey, I have this idea, or hey, I have a, EV motor, and I want to reduce the mass or increase efficiency or something, one of those parameters, we can look and see, not only based on our magnet technology, but in general. And so it's a very interesting tool. It's not something that we would ever do like open source, but it's
understood. Right. Yeah.
It's something that it's a sales, right. And so it's a sales tool. So generally speaking, when a customer comes to AML, they say, hey, we've got an idea, or hey, we've got an existing design, but we want to do something different. We want to get we'll reduce some weight or do something. And we say, okay, give us some specs. We may not even need much. And when we put it into our design exploration tools, we call them design studies. And we do a quick analysis for no cost. The customer can come and we get an idea based on this data plots, where we're looking at, and what's sort of what's doable, what's not doable, what makes sense. And then if there's an interest further, you go into a deep design study. And that goes into a lot more crossover with engineering, et cetera. And so that's one of the things that we actually were doing before we even started producing prototypes, before we started refining, the full manufacturing process in terms of integrating everything. And so,
And I would say, I want to get into our magnet rankings in a minute, but magnet manufacturer rankings. I think what you have developed is important because there is no standardization in the magnet market. They're all tailored to specific types of products, what have you. And so I think there's a lot, correct me if I'm wrong here, there's a lot of customization. So that's a challenge for many vendors, but it's also an opportunity if you have the ability, like you're talking about, to help really vet and qualify and run simulations early on. Would you agree with that?
yeah, and it's also right, correct. It's a good way for us to explore things, with limited sort of pursuit cost. And it's also, our technology sort of goes quote unquote against the grain. I mean, it's not a pun on grain boundary diffusion, but it's one of those things that, it's hard to compare. Like you said, if you look at, there's that chart with all the grades. I mean, it's been around quite a long time and it's very standard. The interesting part, to be honest with you, the last 2 years, at least, I would say specifically in 2025, we've built a lot of relationships with customers, even just collaborations, nothing in terms of definitive exchanging of consideration, but working on concepts, doing a lot of, quote unquote, free work. But what we've seen is there's a more and more customers are starting to look at how do they diversify their supply chain. The neodymium praseodymium supply chain is one of the most, it's heavily manipulated. It's driven, if that price goes up, the mines are happy, the magnet makers are not, vice versa. And so it's a very interesting world. And so, but the one thing a lot of customers are starting to look at is they're looking at performance changes. They're looking at, well, we want to have a supply chain that's a little more continuous and maybe have a more stability. But we'll look at some different materials that compare potentially with a certain design with a sort of grade that you see on that chart. But I think that, I will say that there is, what's changed in the last 2 to 3 years, mostly I'd say the last 2 years, is the openness to not just design changes, but also innovation. Because most motor designers, by example, are only limited to blocks. Their design space is based on something that they can only procure from their supply chain management team. And so they now, I mean, not that they weren't interested before, but I think that there's, through the maturing of our technology and then also, some of the dynamics in the market, I think that folks are just bored and they're looking for something new. And what they're realizing is that something new gives them a reduced cost in assembly, potentially, and more importantly, performance characteristics they're looking for. And everybody knows too that, one of the negating factors is somebody would say, well, hey, if we redesign this motor, we're gonna have to retool the whole manufacturing line. And that's a given, but that's also something you can factor in terms of a cost savings on assembly, and some of the other added value benefits.
Yes. No, that makes sense. Now, if you step back for a second, we founded Rare Earth Exchanges to look at the entire supply chain from upstream, midstream, downstream. Magnets are a key part of that. And we even go into the vertical industries, electric vehicles, defense, etc. Right? Now, we have a ranking and we have 4 divisions because China essentially has monopolized the magnet production over the last couple decades. So if you look at our division 1, it's all Chinese companies. That's because they supply over 90% of the magnets in the world today. And if you look at number 2, there are no American companies, yet there are essentially Japanese companies. I believe they're all Japanese, okay? It's not till Division 3 on the Rare Earth Exchanges rankings that we actually start to see American companies like EEC, which is now Fermag, and I think I pronounced that correctly, and Neo and Novi, and there's a few others. So there's a landscape that's emerging, and we're going to see more and more magnet production happen outside of China, both in Asia, Japan, South Korea, US, some Germany, France, a few other places. How does your company fit into that ecosystem? Like, it's going to be pretty competitive, and what are your targets? Is it defense? Is it electric vehicles? What's your primary market target? What makes you all differentiated as you come to market?
Yeah, and so it's a great, and I hope that we can stay off that ranking for a bit until we get everything in order. But no, it's I think it's, and I actually have looked at that before you guys had it up there, and I kind of went through it, and it makes complete sense. Our target market Is defense? Yes, it's a very big market. We're actually doing most of our demonstrations in defense at this moment in time. One of our existing uh, finance strategic partners and funders is a aerospace and defense firm that's privately held. We see the commercial market for us being mostly motors, industrial motors and generators. That's, we're currently doing some collaborations with one, two, three. I mean, there's at least three of them and multiple projects. Some of them are funded, some of them are self-funded. They're driven by mostly on our non-neo centered side of things. But what we're seeing though is in the United States market is because our technology allows us to do some very unique configurations and with how we magnetize within our process, that there's a very interesting market for centered neomagnets. And, that is something that we plan to scale in the United States. We've looked at all different materials, et cetera. But that is, the United States, there is a huge demand for centered magnets, as you know. We're just at the conference in Toronto and we saw the statistics and the data. And it's quite overwhelming. There's a lot of enthusiasm towards getting into market. But how we differentiate is that, while yes, we can produce magnets in blocks with standard equipment, we have the ability to develop and produce magnets that we find that either the innovation is not in the U.S. and perhaps might be in China or in other, specifically China, as you know, that's just the amount of resources and time that they put towards it. And in order to be able to try to do that here for certain things would take decades, if not, and a lot of resources. And so the EV market is an interesting market. I think that there's going to be a divide, as you guys have seen. The question too is, what's the price of a magnet, right? Because the price of a magnet is also the price that your partners are willing to make some money up, downstream. And we've been developing some very interesting strategic relationships across the supply chain. We've been doing that for almost half a decade. We've grown up and watched some of these folks grow as well. And I mentioned before about collaborations and trying to figure out how to work together, to enter this market with a lot of these newcomers, that maybe don't have the experience that the folks in Japan and elsewhere have dealing with how to, the supply chain dynamics, perhaps looking at different designs, redesigning magnet-based applications like motors. And so we see ourselves fitting in a differentiated format. And I think like everybody else, we're still trying to understand how this market will evolve in the United States. Will there be a Western market versus versus a China market, or in terms of pricing, in terms of perhaps customers will be more open-minded to some of the value adds that companies like us can provide. And we're learning just like everybody else. But I think that, I expect that there will definitely be more, there will be more companies entering the US from elsewhere perhaps, but it is a very competitive environment. And, to try to innovate very quickly and produce something that customers want. Many customers for magnets have pretty high criteria, right? And so it's a lot at once.
That's great. So Wade, it'd be interesting to hear about the PM wire technology. I assume that's what you guys are known for. Is that your only product or thing that you're selling to create your stay in the marketplace?
Yeah, so PM wire is a process for producing magnets, and then we've come up with different names based on certain configurations. So PM wire is a process of which we produce magnets, but then how we magnetize and in certain unique magnetizations, we've come up with some different names like PM360. We've come up with something that now is known as PM axial. It's the way it's magnetized. And our CTO came up with it, Dr. Philippe Masson. It's a certain configurations allow us to either bring more out of materials, use materials in a better way. Another side example is with our PM axial, we can actually work with materials, such as mish metal, where it's not as processed. It's a rare earth, but it's not as processed down the line. It's a cheaper material, but we're able to magnetize it in a certain way on a certain side direction that actually benefits the application, like a motor. And additionally, we can reduce the use of heavy rare earths, some of the critical minerals. Those are things that are very interesting to us because what we're seeing is, just like I talked about before, what's the price of getting out of, say, China without innovating? You have to look at innovation both to reduce costs and also add value. And so what we're going through in terms of our discovery is that both from the defense and the industrial side is folks are starting to look at these different designs and saying, wait a second, we've always designed based on something that was, say, invented 30, 40 years ago. We're trying to innovate our products now. Maybe we should look at this differently too. And so PM wire is a process of which we produce our magnets, and then we haven't come up with different names for everything, but there are a couple different products per se that we've developed that, based on a certain magnetization, have a unique sort of market in terms of their naming and their product.
Okay, that's helpful to know. Are you guys getting into the recycling space at all, or are you building kind of from scratch from new magnets? It seems like getting a feedstock from a mine from processed oxide is a challenge or not feasible. So people are turning to recycling. What are your thoughts on that?
I think recycling is awesome. I'll actually give a shout out to Reelement Technologies because they're actually a stakeholder of ours. Their parent company is. Their CEOs on our board of directors. So, yeah, Mark and his team have done a great job. We are very familiar with the recycling world, and we see that as a huge important thing for the United States, especially when you're trying to stage and expand the feedstock, because we all know that feedstock is the current discussion. And based on even going to some of these conferences, everybody seems to have a lot of feedstock down the road, but what's today is a bigger concern. And so recycling is a very important way to be able to, one, obviously do something that's important for the environment, reduce the amount of items going in the landfills, especially, electric vehicles and different things, wind turbines, power tools, electronics, you name it. Anything with a magnet in there for us is where we get our new recycled rare earths from. We see that as a very important aspect. We know that there's only going to be so much that can add to the rare earth oxide supply chain. We do see that as it's a key element to jumpstart the United States supply of rare earths.
Great. And do you guys have the capabilities to take e-waste and recycle it, or are you guys going to need someone else to do that and then you guys can take it from there?
We don't do any recycling. We partner with those that recycle. So like I mentioned earlier, where one of our suppliers is Reelement Technologies, and they do all of that. But we can take the oxides and then through the remaining steps through our remaining supply chain to then be able to make magnets. And that's but yeah, we don't recycle. We'll definitely send them feedstock from people, but we don't recycle.
And then kind of shifting gears just a little bit, in terms of scaling your operation, what would you say is probably your biggest challenge in just increasing that production so that you can maybe take on more customers, things like that? What's the big roadblock?
I think it's for one, obviously it's capital, but I think that it's sort of two-pronged. It's supply chain and capital. And a lot of that's actually, we're at a point now in figuring a lot of that out. And what we've seen, I think that this discussion too on the market, because a lot of the other companies, the bigger names or the ones that you'd consider more mature, I mean, many of them are coming online now. And they've been at it just like us for several years, because it takes, making magnets is not easy. And so it's been a chicken or the egg, because the customers in the United States, they're all, they source globally magnets. It's been very difficult to pinpoint folks in a supply chain team and say, look, what percentage are you going to get from us from the United States? What are you willing to pay? What are you willing to do? And those conversations, I think, are increasing at a higher rate. And just like with the trade war happened in April, we started getting a lot of reach outs with panic companies, fully knowing that we're not ready yet to produce for them, but we would listen to them and say, we understand what your concerns are, but we'd like to get some more information and figure out how we can help you soon enough. But over time, we've started to get a lot more interest. And I think that's based on the fundamentals of folks wanting to eventually source outside of those areas. And from a scaling standpoint, now that gets you a more captive audience, and you start to have a market to where you're targeting, and your suppliers are starting to understand that too. And then, going from that, the next stage, working within, everybody wants non-dilutive funding or at least cost share. So, within the DoD or the DOE or wherever, looking for some cost share there is always great. But, we're at a point now with moving our business to a point of scaling and entering the market. We're going to enter the market likely at, within the centered, and then we're going to enter, for the general sort of infrastructure that we're putting together. And then as we go through these demonstrations on some of the other magnet materials, we will go to market with them. And our business model is generally, we're going to be a manufacturer. We may spin out a company just for manufacturing, even a certain, say, sintered. It's starting to make a lot of sense and it's starting to really get real. But because of some of the interest in the supply chain we have, and also some of those that are on the investment side are starting to really understand the dynamics. Clearly, a lot of the interesting stuff going on between private sector and government has driven some of that interest, because everything flows down to the magnet company, and the magnet company seems to be the driver for the pull and the value. And given the fact that we're in a position where we're I would say a mid to late stage startup, we can move pretty quickly. We've gathered a lot of interest, and so now we're at that point of, okay, what is the optimal mix to scale, but also looking at value driven products. We're not trying to do 10,000 metric tons by 2027. We're going to be looking at something that's quite less than that, but within a reason of the product mix, because we're focused on value and meeting sort of the unmet need that we're starting to see. So impact versus quantity is the impact is the real important thing that we're looking to achieve. Specifically targeted more for defense. I think that's what we're seeing is the industrial base in the United States is just hungry for innovation. They're hungry for solutions, and we don't want to have the calendar fast forward a year from now and not be able to meet some of those needs. And so last 3 or 4 months we've been running around the globe, well, mostly the U.S., but meeting with supply chain partners, understanding dynamics a little bit within our government, and putting those pieces together that makes sense to not only build a business, say that the industrial base that's leaning towards defense, but also for the industry, commercial markets.
That's really interesting. How much more runway do you think you guys need before you can start delivering to the Department of Defense and other interested parties who want what you are offering?
Yeah. So at this point right now, we are delivering prototypes we're actually on our second project with a defense company for one of our configurations. We have had a longstanding relationship with the Defense Logistics Agency, and we are, working with some of the other agencies too for defense to deliver prototypes, et cetera. So we're going down that path as we exist today. And then we're laying out our manufacturing plan for scale up, that we're going to start, quote unquote, breaking ground. We're focused on trying to start that early next year. It could be sooner, but getting these pieces together and sort of setting the trajectory is probably the most important thing for us. But yeah, we're engaged in prototyping right now, qualification.
So it sounds like you're gearing up for a 2026 go to market where you're actually in production. You're targeting value added, motors, sort of specific sub segment markets where you can add, more value. And so it's less about scale and it's more about value add in specific value chains. And you've got those, it sounds like, mapped out pretty well based on the prototyping and the partnerships of the last few years. Is that a fair assumption?
Yes, correct.
So basically, if there were investors interested, I mean, we have a lot of investors coming through rare earth exchanges. Would you have sort of a business plan and a forum to be able to speak with them? I mean, do you have events, or what are some ways that you reach out to, let's just say, investors as an example?
Yeah, if there's some interested investors, they can find us through our website, find me on LinkedIn. We are putting together that plan. So yeah, we are. I mean, obviously, we're interested in talking to like-minded people that are patriotic and want to, do something that's different, that's tactical, that's very strategic, and happy to have them come by our facilities in Melbourne, Florida, meet our team, myself and our CTO, and for us, like I said, now we're at a point where we put a lot of these things together, and yeah, we're open for visitors, as well as just having fun conversations about the challenges of the world.
Yeah, and I would
Sounds
just
like
say
a great time.
Yeah, for sure. I would say it's very, important to educate markets, investors, potential customers about these supply chain dynamics. Wade, we have learned there are large defense companies, let us say, that may not truly understand the dynamics of their supply chain. There's a lot of education happening. It's an exciting time because America is reindustrializing. We actually have a president that cares about that. And so it's a very exciting time. And, we're observing a lot of the growing interest. So we look at companies such as yours as instrumental over the next 5 to 10 years to be growing and to be part of that new industrial industrialize or reindustrialize supply chain, value chain. Make sense?
Yeah, most definitely. And we've, one of the exciting things for us, I mean, one of the things I enjoy the most is working with within the supply chain and all the moving pieces and dynamics. We have a pretty even keeled perspective because we've covered such a wide space. We've, from the mines to the separators to the folks that are sort of in between to the folks trying to figure out their place in the metals to figuring out the alloys to the magnets. And so we have a high level of respect for everybody in the supply chain because it's very difficult. And folks may, think that being a magnet company is the cherry on top, but it also, requires us to really understand our supply chain because as we start to develop this, let's call it this new supply chain for magnets that's outside of China, everybody's going to have to understand what the business case is because, once you develop your technology, you develop some prototype line, you start looking at use cases, and then you start realizing that, at the end of the day, it's still a business. It only invigorates in terms of the importance of really trying to collaborate and work together and coming up with interesting and innovative ideas of working in business, not just the technologies. I think that while vertical integration is great and there's lots of sort of tried and true, traditional strategies that people have looked at in this sector, I think that there's also, there's a win-win out there. It's just a matter of everybody figuring out how to work together.
Well, this is very important, Wade. And Dustin, cut me off if we're running over. The competition is formidable. It's a state-backed, virtually integrated behemoth. You can think of it as the Death Star, and you're Luke Skywalker. Okay. So that's not far from the analogy. In fact, we have an image of that. We've spoken with people both in the U.S. and China about the operations over there, and we track it very carefully. Now, they have a scale and they have a head start that is, beyond formidable. However, we're seeing signs of a rigidity and a sort of a politicization of their industry. Because what's happened is the Communist Party is starting to get a little nervous and they're starting to clamp down on all the industry. And the industry, they're just like you and I. They're people that they want to innovate. They want to do their thing. They don't want to have to, if you're working over at a Chinese magnet company, you have, before you go on vacation somewhere in the world with your family, you got to check in. Okay. And that's thousands of people. So the innovation is going to happen over here in many ways, exactly with what you're doing. So we want to make sure that as you look longer term, share with us, where would you like to be in 5 years, your company? Kind of walk us through the vision so that everybody can hear it.
Yeah. So I think with the next 5 years, what we want to do is we want to be developing, some marquee customer relationships, commercializing, multiple different types of magnet materials within magnets, making an impact, developing, solutions for defense that give us a stronger sense of actual national security and, potentially, developing magnets with less critical rare earths, even non-rare earths. I mean, our process is very innovative. And I think that, the important thing is to sort of change the industry and really for folks to understand that, there is a better way to say make an electrical machine or a motor or an application, and that we can solve this problem very quickly, especially as it relates to, the main bottlenecks that you see out there. Both how do you produce things economically in an environment like the United States? How do you, reduce waste? How do you develop value add for magnet-based applications? And the other thing is really looking at the periodic table and looking at all these rare earths and understanding that, by example, Mountain Pass may have a lot of cerium and a lot of samarium, or maybe not a lot of samarium, but a lot of lanthanum and cerium. Maybe that's something that could be, if used in a right configuration, could be very applicable for applications no one ever thought. And so making a better use of the resources we have is really, really, really important. And because otherwise you're just going to be trying to pull more out of the ground from a different place or from somewhere else, or may never actually get it, in terms of, dysprosium and terbium. That might be a bigger challenge than anyone is ready to face. And so I think being a part of that change and giving, others, the opportunity to succeed within a supply chain too, because we can do something a little different, opening up doors, opening up markets. It's really important to us. And I think that that's one of the things that really drives us from the tactical standpoint of being able to, do something different, yes. Be able to fit in with the mainstream and to affect it in a positive way is really important to us because, there's only so many resources in the world, and you have to be able to either use them wisely or use them in a better way. So, um, our hope is, to be honest, is to develop even more innovation. This is just the beginning of what we're doing, and that it actually has some benefits, to not only just industry but society in general. And eventually there won't even be a U.S. China trade war, so we'll just be one happy planet.
Yeah, that's very exciting. Wade, very, very exciting. We're going to support you any way we can. Dustin, do you want to?
Yep. So Wade, I really liked what you said there. We really, as a community, need to be more creative with the resources we already have access to and see if we can do more with them. So I support that mission and hope to see that come to fruition over the next few years because I think it'll become a really big deal. So with that, Wade, thank you so much for joining us here on the podcast and sharing a bit about you, your company, and your endeavors. So we hope to have you on the show again in the future to get an update, see where things are at, and how people can be even more involved in what you guys are doing. So we appreciate it.
Absolutely. Maybe next time we can do it in person at the facility.
Yeah, well, looking
Be
at your
awesome.
background there with all the robots and stuff, that'd be awesome. We should do it.
100%.
Awesome.
Great.
Well,
Everyone,
thank you
thanks
so
for
much.
listening, and we will catch you guys next week in our next episode.
Yep. Thank you.